Hello. So, welcome to this session. It's a talk and concert. And let me make an introduction first by presenting the author of the piece that you're going to listen to. It's Pedro Louzeiro. He's a composer. He's a composer and a professor at the Lolé Music Conservatorium. And he's being accompanied by Vasco, help me out please, Vasco Ramalho, who is also a professor at the Conservatorium. And we have the pleasure of having here also the director of the Lolé Conservatorium, who's been working with us in a project, a joint project, relating, or trying to relate music and water, or nature-based issues. And so this is, as you may see from the, or may have seen from the brochure, that the piece is called HydroSonic 2. And it's 2 because this is in fact the second. The first session ran in the Lolé Conservatorium, and Pedro Louzeiro prepared a piece based on regional hydroclimatic time series. And so what you're going to listen to is a piece based on hydroclimatic time series from the Algarve, which go from the coast until the hills. So in part they reflect this gradient, but also the different components in the water cycle. And he's made the excellent piece in the first session, which was in the conservatorium, as I said. And during that session, we not only made the music, but also took the opportunity to discuss with students and show students part of the water cycle that they usually do not see. It's the groundwater. And so we carried with us a physical groundwater and used that physical groundwater model to show students and the rest of the attendants how groundwater works and how the groundwater affects surface water and how contamination moves in groundwater. And I think it was quite enlightening at the time. And so what we did was we took science into the conservatorium, and now the second stage, are we taking music from the conservatorium to the university. So thank you for coming, and I hope you enjoy. Pedro will do a talk and a concert, so he's going to explain how he transform this time series into his music. Pedro, the stage is yours.
Thank you very much. Well, first of all, I would like to thank Professor Luís Nunes and the University of Algarve for this invitation. That's quite an honor to be here. And I will, as Luís said, I will talk about this piece that is going to be performed here by the first time by Vasco Ramalho, the percussionist. And so this piece uses a technique called sonification, data sonification. In fact, Professor Luís actually kind of introduced me to this technique. I had already known about it, but I have never experienced doing any work with that technique. Luís sent us to the Conservatory of Lolé this initial proposal to do something creative with these science data sets, scientific data sets, and he actually did some experiments in spreadsheets with some formulas to convert these temporal data sets into music notation. He used these formulas and also some web applications to convert the musical data into musical notation. And I enjoyed it very much. And of course, I accepted the challenge of composing a piece with this technique. And this is the second piece, as Luis said. So it's actually based on the first piece, but in an extended version and using more data sets. So sonification, what is it? What is it? When you interpret temporal data, you can either use a graph to visualize the data. That's what you normally do, right? You use a graph, and you have on the x-axis the time, and on the vertical axis you have your values, right? So, but if you consider that a musical score is also a graph, which is the same thing actually, you have time on the horizontal axis, and you have pitch on the vertical. And now I would like to ask you to show in a raise of hands. Is there any musicians among you? Professional or hobbyist? Okay. Oh, okay. Anyone has some degree of musical training, piano lessons or something like that? Okay, good. So let's see. This is a musical score notation. This one is called C, okay? And it sounds like this. Okay, this is a C. So let's sing what's there. C, D, E. Okay, that's not too hard, is it? Okay, that's not really hard. Let's see how well did you do. Perfect, right? Okay, so that's what I mean. You have time on the horizontal axis, and you have pitch on the vertical axis. If you look at some of these temporal data series, you can translate it directly to a melody just by snapping it to the grid, to the musical grid. But then some how do I say this? Some data sets are quite interesting to transform into a melody, and some others may be a bit boring or not that interesting in musical terms, if you think about it as melody. But music has other parameters. Rhythm, timbre, which is the quality of the sound, intensity of the sound. When you're considering electronic music, you can also have the directionality of the sound, spatialization, and I would like to point out that we have a four channels system here. These two channels and two more in the back. So the sweet spot for listening will be here in the center. So by the way, those of you who are more far to that side, maybe if you can approach the center, it will be better for listening. And so the idea was to grab, for example, well, the most obvious is the precipitation, rainfall. Rainfall, we can transform it into a melody, for example. And rainfall is actually quite a nice data set because it doesn't rain every day. Okay, so that allows for rhythm to occur naturally, and the melody must have rhythm. Okay, so that was important. There are other types of data sets that I found interesting. For example, evapotranspiration, because it varies a lot. It has like a tendency of going upwards in the summer, but it varies during the day, during well, day by day. But then it always has some value, right? So you can't really have rhythm if there's always some value to quantify or to turn into music. But there are other possibilities. For example, wind direction. Wind direction is very nice because as we have this spatial setup here, I can translate the direction of the wind to the direction that the sound is coming from. Okay. Another one is the how do you say this in English? Sorry. The flow, the river, the water flow. Can you help me out, please? Flow in the river. Yeah. Okay. So turning. Well, here we have quite small rivers, and in the summer they are normally dry, and in the winter they carry water, right? So it has a rhythm, but maybe not so interesting to create a melody because you have too much space between, well, between winter and the next winter, right? So, but it helps to show well, we can translate it to a musical form, right? Either you have water in the river or you don't. And you can have too much water or too little water, and that can be translated to music as well. For example, in the first piece that we did, which actually corresponds to the first half of the piece that we are going to be playing today, there is an effect that we call delay, which is actually an echo. So there is an echo effect that travels from here, from the stage, to the back of the room. And of course, I didn't really think this through because the room goes uphill, so the water always comes downhill. So maybe next time that I'm present in a place like this, I will think this through. But the thought was, here is north, and where you are is south, and the water here in the Algarve always flows from north to south. So yeah, so this is these are the most obvious aspects of when we are listening to this piece. The percussion will represent the rainfall. So if there is no sound, it's a dry day with no rain. If a low note is played, then there is little rain. If a high-pitched note is played, then there is lots of rain. This is the mapping, very obvious mapping as you would do in a graph that translates to a musical score. And then there is this echo effect that represents the rivers that carry water when there is rain. You will of course notice it that if the percussion is not playing very much, then there is not enough rain to trigger water in the river, or in other words, to trigger the delay, the echo effect. And then the other series that I used was the evapotranspiration. Evapotranspiration is always varying, as I said before, and it tends to be higher in the summer. So you will hear a continuum of sounds that will represent this evapotranspiration, and you will notice that they will go up in the summer. How do you know this? Because there is no rain, so there is no percussion being played. Maybe it's a good idea for me to show you what sounds I'm referring to, so you'll get a better notion of what it is. It's actually a very cool effect because it's called subtractive synthesis, which is a type of synthesis where you start with noise. I'll show you. That was white noise, so all the frequencies have the same power. But then, if I subtract all, I just did subtract all, you have silence. But if I let just a few of them, you get these really nice sounds. And so it is called subtractive synthesis. And the idea of evapotranspiration is also a subtraction of water from the ground. We talked, me and Luis, about this, and we found that conceptually that's a very interesting idea. So the first half of the piece is this idea I've already described. By the way, that instrument, the percussion, the acoustic one, is called balafon. Which is a West African instrument, which is like the grandfather of the marimba, we can say so. And that's the first half of the piece. In the summer, so you'll see that these sounds will go higher, but there is also some rumble that is occurring, but that was more like artistic freedom, if you will. I just mapped the highest point beyond the threshold of evapotranspiration for the evapotranspiration, the sounds to come from beneath once again. And then the second part. Oh, one more thing. All these data sets from the first part are from the weather station of Faro. The next part of the music. The data sets are from Alte, from another weather station, which is in the mountains, or in the hills, not mountains. What else? Okay. One new thing that I used was the data from bore wells, and I think the bore wells, which you can correct me if I'm wrong, but they are from many places in the Algarve, right? Okay, so there are 5 bore wells, which we can measure the depth of the water, the depth of the groundwater. And of course, it goes down during the summer. And when it is a dry summer, in particular, it can go, well, you know better than me, right? You're experts in this field. In this newest section of this second part of the piece, the percussion instrument will be that top one that you see there. It's a digital controller. It's like a MIDI keyboard, but for percussionists to be able to play. And so in this part of the music, it will trigger sounds, synthesized sounds, and those sounds will be the timbre of those sounds will be manipulated by different data sets. And there is also a very low drone sound that will reflect or will represent the water table levels. So when it goes down, that drone will go very, very low. It's actually only affecting the sound beneath a certain threshold, so that it's not always changing, because that's a bit kind of a problem with transforming this series to music, is that it's very continuum, very glissando-like or gliding musical effect. And so, in order to have some stability, when the water is high in the water table, the drone is at the same pitch. But then when it's getting when it's motive for concern, because it's too low, then you'll get this effect of okay. But of course, the other thing is the timbre, the quality of the sound, which is affected also by these different bore wells. So I have 5 bore wells, or data from 5 bore wells, and I use an additive synth. This one was a subtractive. This one that you've just listened, that's subtractive synthesis. The one that I'm talking about now is additive synthesis. It's better that I show you what I mean. So when you have additive synthesis, you can add harmonic frequencies, and they are harmonic because their frequency is like a multiple of the fundamental frequency, in order to create a timbre. Let me show you. So this is the fundamental sound. An interval of an octave. And then if you multiply the fundamental frequency by 3, you get this sound. And by 4, you get this sound. Of course, 4 is the double of 2, so it's an octave higher than this one. And then this sound, and so on. How many sounds am I playing? 7, right? Actually, I'm playing just 1. But it's a complex sound, right? You can actually simulate timbres from many instruments. For example, what instrument do you think this is? It's not working, why? Funny, but not funny. It's not working. Well, I can do it manually, I guess. So, what instrument would you say this is? Maybe a clarinet? Maybe. Okay. Didn't work so well this time. What about this one? It's distorting a bit. Any clues? Okay, it would be an oboe. Anyway, let me see. So, well, back to the Borel stuff. different levels of the bore wells will affect the other synthesizer, the other additive synthesizer that I have, and yeah, so maybe let's look at that. Okay. So what I mean is we have five data sets, and we have 20 harmonics on that other synth that I'm using. 20 harmonics. So what happens is I'm using data from one bore well to 4 harmonics, and I did some remapping. No, still no go. So here, no é este. Oh, this is, no, not this one. Voila. So one bore well controls 4 harmonics, and you can see that when the water goes down, the harmonics go up, but they don't go up evenly, right? The only one that's going linearly is the first one, this one here. Linear, but inverse to the level. The other ones are mapped by the same value, but they have another function that's remapping the values. So, for example, the second and the fourth use a logarithmic function with some difference in the base of the function, and the last one uses a sine function, which means it will go down actually when we're reaching the end of the scale. So this is to allow for timbral diversity. It's not an accurate representation of the data, but it's once again some artistic freedom that I think I'm entitled to. So I think I've talked enough. And maybe we should listen to a bit of music now. Mm-hmm. Okay. Oh, there's just one thing that I wanted to address as well. Is there is another type of synthesis, which is granular synthesis, which I think I can show you here. Okay, something like this. Which I'm using. This is so that you can relate to what I've been saying when you're hearing the piece. In this second part, the percussionist will be playing on the top instrument, and when he reaches a higher note, that's because there was a higher an event of more rain, like a heavy rain event, and so. I was inspired by the sound engineering thing that you will always look for a meter of the volume, so that when it surpasses certain thresholds, it marks in red that the sound is being distorted because you've reached this point. So here is the same thing. When he reaches a higher note, that level stays there with the sound similar to this one. Okay, so when you hear it, you know that represents an event of more rain, heavier rain. Well, yeah, that's it. Let's welcome Vasco Ramalho on stage. I've just been told that it's raining outside. So, I hope you enjoyed it. Obrigado.